The history of a civil engineering. Civil engineering is the oldest branches of engineering which is growing right from the Stone Age of our civilization and profession designing, constructing, maintaining the earth environment. A wide range of our infrastructure projects like a road, bridge, building, and waste system and etc. Stone Age shelter that used to protect the weather and harsh environment. Stone Age blade axes were a very important useful tools. And the last is irrigation. Irrigation have a 8 part. The pivot irrigation, surface irrigation, sprinkler irrigation, drip irrigation system, localized microsystem, furrow irrigation, and sub-irrigation. The father of a civil engineering, John Stempton, who born on June 8, 1729, come from civil engineering, responsible for designing the bridge, canal, harbor, and lighthouse. First engineer, M. Joseph. He built a producer, first registered engineer. Marshal Calisag, first president of Philippine Society, Civil Engineering. He was also a 19th U.S. of prominent civil engineering in early 20th century. First person called herself civil engineering, John Stempton.
Good day everyone, my name is Chrisara P. Barbon, a BE CE1. So today I will tackle about structural engineering. So structural engineering is a field of engineering that dealing with analysis and design of structures that support or resist heavy load. In structural engineering, there's a specialties for building structure. So first is the earthquake engineering, engineering, fire engineering, roof engineering, tower engineering, and the last one is the wind engineering. So these are the specialties for building structures. So in structural engineering, there's a types of structures and their design. So first is the buildings, bridges, spatial structure, and sustainability and resilient design.
Let's talk about geotechnical engineering. For your understanding, what is geotechnical engineering? Geotechnical engineering mostly focuses on railways, roads, foundation, retaining walls, and mitigating natural hazards like landslide and earthquakes. Geotechnical engineering is a branch of civil engineering that studies the mechanical behavior of soils and rocks to guide the design and safety infrastructure projects such as roads, railways, foundation, retaining walls, and to mitigate natural hazards like natural disaster. This geotechnical engineering prevents how infrastructure build, and also they manage and observe the soil of the site of your project, which is can prevent your project to later easily destroyed by natural disaster. Geotechnical engineering incorporates two scientific specialisms, geotechnics and engineering geology. Geotechnics, applying scientific principles to engineering challenges involving with earth materials, which is like soil and rocks. They studied the foundation of how you create your project, while engineering geology using geological knowledge of soil and rock behavior in engineering context, which is engineering geology. They study soils and rock also, but they have observation on how the soil, how the land formates, and also to prevent any more accidents in the near future. Geotechnical versus structural engineering. Geotechnical and structural engineering are disciplines of civil engineering, and both are critical to infrastructure project. Who is geotechnical engineering and what do they do? A geotechnical engineering is a civil engineer specialized in earth materials. They perform site investigation, laboratory reports, laboratory testing, and modeling to assess the physical, mechanical, and chemical properties of soil and rocks. Which is the geotechnical engineer is the one who studied the soil. Like you have a project and you want to build it in that land. Geotechnical engineering will investigate that land so that your project or your future infrastructure that you build in that land will not be affected by the natural phenomena of land. Like you have a landslide in your area, it can prevent that you can't have your building in that area, because geotechnical engineering will tell you that that land will be hazardous for building. Typical responsibility of geotechnical engineering: planning and overseeing site investigation to understand surface, subsurface condition. And second is conducting laboratory tests to measure soil properties, which I said earlier, they can prevent any damages in the near future. Why does geotechnical engineering matter? Geotechnical engineering ensures that our ground conditions are properly understood and managed before constructions, such as said earlier. Proper investigation and analysis help avoid costly design errors, structural failures, and environmental impacts. Tools like tensors. So, the geotechnical engineering studies the soil, the land, to prevent infrastructure or building that you made in that specific land, to prevent it to fall or damage in the near future. They can prevent you to get your geotechnical engineering, which is prevent your land to landslide. They have tools and equipment to prevent your land to have to have your infrastructure get destroyed or fall. So they have you advise early on, because they have the laboratory test of your land and the observation of its position, and that's all.
Water engineering. Water engineering is a specialized branch of civil and environmental engineering focused on the movement, treatment, distribution, and management of water for human, industrial, agriculture, and environmental needs. It integrates principles from hydrology, hydraulic, chemistry, geology, ecology, and environmental management to ensure sustainable water use and protection. Historical background: ancient civilization, Mesopotamians, irrigation canals, Roman, aqueducts, sewer, Indus Valley, urban drainage. Medieval period, development of water wheels, dams, and canals. Modern era, large scale dams, water treatment, and wastewater management systems. Main branches: water supply engineering, wastewater engineering, hydraulic engineering, irrigation and agricultural water engineering, hydropower engineering, environmental and water resources engineering, coastal and ocean engineering. Career opportunities: roles include water supply engineer, wastewater engineer, hydraulic engineer, flood risk engineer, irrigation engineer, hydropower engineer, and water resources manager. In essence, water engineers ensure reliable access to clean water, manage wastewater, and protect communities from floods and drought, balancing human needs with environmental sustainability. And that's all. Thank you.
Hello everyone, I am Ahmad Rashid Medina. So this is my topic for the report, the civil engineering and the environmental science. So first, what is civil engineering? Civil engineering is a professional engineering discipline focused on the design, construction, and maintenance of the built environment. This includes large-scale public and private works essential to modern civilization. So, ang civil engineering is nag-focus siya sa mga infrastructure like roads, bridge, railways, and mga water sources like dams, canals, and water supply network o flood control system. Ang civil engineering na ay duha ka categories, which is structural engineering ug ang constructional engineering. Ang constructional engineering focuses on planning, manage, and mag-execute. Next, structural engineering. Structural engineering is focuses on buildings, towers, stadium, and other load-bearing structure. And next is environmental science. Environmental science is an interdisciplinary academic field that integrates physical, biological, and information science to study the environment and the solution of environmental problems. Like kanang pollution, hangin, tubig o yuta dayon nag-focus ni siya unsa ang pag-sustain sa mga possible na mahitabo pag-abot sa mga climate change, mga kalamidad bitaw like mga earthquake, bagyo ug uban pa. So this is the difference between civil engineering and environmental science. Civil engineering and environmental science are two distinct but increasingly intertwined fields focused on improving the world around us. Civil engineering is primarily an applied discipline focused on the built environment, while environmental science is a more research-oriented field focused on the natural environment. So this is the relationship between the two. Civil engineering and environmental science is very close and interdependent. Both fields work together to ensure that infrastructure development is safe, sustainable, and environmentally responsible. Once again, I am Ahmad Rashid Medina. I'm the reporter of this topic. Thank you.